Hi friends, my name is Kat, and today I'm here to talk to you about Shewhart charts. Specifically, we're going to be looking at Shewhart charts for attribute data today. Okay, so we are in SAS Studio, and if you're using SAS Studio, by the way, if you go down below, you can get a link to the data that I'm using here. This data set is called Surgery, and the surgery data set is recording the number of complications that surgical patients had each day. And because a patient can have more than one complication in a day, this is a Poisson counting process. We also have a variable in the data set, patients, which is the number of patients who were operated on that day. I'm going to start out with a U chart. So Proc-Shewhart is the procedure we use to create control charts, and the U chart statement is what we use to plot the Poisson counting process, especially if your area of opportunity varies or changes from day to day, which it does in this case. So if I run this first Proc-Shewhart call, it's going to request a U chart, which will plot the count of complications per patient per day. And when that comes up, we'll see that, oh, it looks like we have two charts. Why do we have two charts? The reason we have two charts is that Proc-Shewhart by default only fits a certain number of subgroups on a panel before it goes to a new panel. That way it doesn't try and squeeze all of your data into one place. Well, maybe you want to squeeze all of your data in one place. I do. I want to squeeze all of the days into a single chart. So the first thing I'm going to do is show you how to make it do that. And that's with this option, tote panels equals 1. So with the tote panels equals 1 option, I'll be able to see all of the days. There's 100 days here. I'll be able to see all 100 days on a single panel. And whoa, look at that. This control chart is all over the map. There are observations that are way too high and way too low, and those control limits are just kind of squeezed around the middle there. Turns out what you're seeing is a phenomenon that's fairly common with attribute data. It turns out that those control limits, which are supposed to compare the between group variability to the within group variability, well, the estimate of, it's not really within group, kind of is, but kind of isn't, not with a Poisson distribution. So the estimate of the variability that we're using for the samples here compared to the between group variability is actually very small when the sample size is large. And in this case, it is. The sample sizes range from 102 to 215 observations per day, number of patients per day. So there's this phenomenon where the control limits end up being really just too tight, even if the process is in control. There's a common fix that people use for this. One way of fixing this is by using an individual and moving range chart. So it is common practice when you have a very large sample size for a binomial or for a Poisson process that you end up using an individual moving range chart in that case. So let's see what happens if we use our individual moving range chart for our surgery data set, looking at the number of complications by day. There we go. Okay, so all of it, again, it's all on one panel because we're using tote panels equals 1. But everything's inside the limits. That's great. Everything's inside the limits. There's one problem though. The problem is that we have different numbers of patients each day. The area of opportunity is different on different days. And it bothers me to have flat control limits that don't account for the fact that I have different numbers of patients each day. So I would really like to be able to use a chart that accounts for the number of patients, but that gives me an estimate of the between group variability that is more appropriate when we have these very large samples for the amount of variability we actually expect to happen day to day for a controlled process. And that's where we turn to our next option. I'm going to modify the code for this analysis. You can see here what we've got is the U chart statement, but I've added in this option right here, Laney, the Laney option. It's just a single keyword. David Laney has published several papers. You can check it out down in the description below, where there are these adjustments that can be made to these kind of limits so that they accommodate this sampling variability and under the very large counts that we're seeing here with the attribute distributions. So we've plugged in the Laney option, and this will now do a correction to the control limits on the U-chart, but it's still going to account for the fact that we have different numbers of patients being operated on each day. I love this option. And you can see in the label at the top, this is now called a U-prime chart, And in fact, it is accommodating the fact that we have between 102 and 215 patients operated on each day, and all the points are inside control limits. Fantastic. It's so exciting. So now what I want to do is save out these control limits and use them to apply to future data. That's going to be the last thing I'm showing you here. You save out the control limits just like you would for any other control chart by putting the out limits equals option on the charting statement. And then when you want to apply those limits, you would specify that limit data set on the Proc-Schuchart statement with the limits equals option. So that's how we would do that. I don't need to run this because it's not going to show you anything except the exact same chart, but that's how we do it. Okay, so that was Schuchart charts for attribute data with some really cool bells and whistles. I hope you enjoyed it. If you liked this video, please give it a thumbs up. Leave me a comment below. I love to hear from you all when you watch my videos. Also, check out the resources below. You'll find documentation, you'll find some papers you can read, you'll find links to courses, all kinds of good stuff. And I love having you here at the SAS Users channel. Make sure that you subscribe to the SAS Users channel, and I'll see you next time.